Okay, the session is being recorded. So the recording I always post it in your Google Classroom. So this will help you in recalling some of the statements which I speak during the class. Okay, so you can always refer those things. So what we were doing, we tried to convert your cylindrical coordinate system into rectangular coordinate system. So just let us take a reference XYZ. So what we wanted to do, we wanted to convert your cylindrical coordinate system into rectangular coordinate system. So in cylindrical coordinate system, I told you that the coordinates are defined like r, phi, and z. Okay. So yesterday I referred the book, and I came to know that I was doing something wrong. The variable which I am taking that is not same as in the book. So the book which I am referring is just I will write it. It is Engineering Electromagnetics. I don't know it is available online or not, but I am referring this, and it will be best if you could also refer this same book, because then you will be able to relate many points which I could have skipped. So this is Engineering Electromagnetics. The one I am using is 7th edition. This book, the author is W.H.A. J.A. Buck. We normally call it Buck. Okay, and the publication is Tata McGrath, TMH. Okay, in this book you will find very beautiful explanation of the physical interpretation of all the concepts which I give it to you. All those things are you will find in this book. So you can always refer these books for extra information which I used to skip. Okay, so in this book the coordinate is for cylindrical coordinate system. It is rho, phi, and z. Okay, before this I have taken r, phi, z. So do not get confused. I will rub this thing. Okay, now we will consider r, phi, z as to be our the three coordinates. Okay, where rho is defined if there is a p point. Okay, so we can take the reflection of this p point. Let us take the reflection on positive xy plane. Yesterday I saw Yukti did it. Yukti did took the positive xy, not the negative xy. I like that thing. So I will also use the same thing. So this is P dash. Okay, the reflection of point P onto your xy plane. Okay, it is P dash. Now we join your origin to your P dash, and this is what? This is R, the radius. Now this is phi. Now people are making mistake. What they are doing? They are somebody has joined, but doesn't matter. Okay. What they have done? They have done a mistake that they have taken this as to be an arc. Okay, and then they are saying that this is x, this is y. This is xy intercept. This is x intercept. This is y intercept. But this is wrong. Okay, why this is wrong? You need to draw perpendicular from here. You need to draw the perpendicular. So this will be perpendicular. Then only you can get this right angle of OP dash and let me say x. This is x-axis, y-axis. Okay, so this OP dash and x, this should be right angle triangle. Then only you can take this x coordinate from Pythagoras theorems. You can determine this x by Pythagoras theorem. So you need to observe these things. These are small points which will be very helpful in understanding the subsequent lectures. So now I can draw one line perpendicular to your y-axis. So this will be the line. Okay. So we can say this is perpendicular. Okay, and this will be y point. Okay, this OYP dash will be a right angle triangle. Now you can apply your geometrical technique. Now what you have to do, you have to convert this r phi z to x, y and z. It means somebody will give you the coordinates of P in rho, phi and z terms, and you have to determine x, y and z. So what the people is asking you, he is saying that tell me this thing, x as a function of rho, phi and z. So you need to observe this thing. X will be a function of rho, phi and z, because at the initial point you are only given rho, phi and z. So if we have to determine x, then x should be a function of rho, phi and z. Similarly, y should be a function of rho, phi and z. Similarly, z will be a function of rho, phi and z. So just see, let us apply the trigonometric law in this triangle OP dash x. So Let me rub some of this part. Okay, let us take okay, do it here only. So in, let me take another ink so that we can highlight this. So in triangle OP dash X, I'm going very slow and to very basics. So just see in this right angle triangle OP dash X, what is the base and what is the height. So in right angle triangle, the angle which is 90 degree, that is between base and height. Okay, the hypotenuse will not make any 90 degree angle. So here you can see this OX and XP dash makes your base and height. So height will be your XP dash and base will be your OX, and this OP dash will be your hypotenuse. So if we write cos theta, cos phi, sorry. So cos phi will be what? It will be OX, that is X upon R, the base divided by hypotenuse. And similarly you can write sin phi has to be y upon R, because this is what? This is the perpendicular distance divided by hypotenuse. So this is a simple thing, simple geometry. So from here we can take X as to be R cos phi and Y has to be R sin phi. See here, these are very basic thing, very small thing, but you need to observe the important points. What is the important point here? X is a function of R and phi. Sorry, we are taking here R na. We should take rho. We have changed the dimension. Sorry for that. Okay. So I'm taking rho everywhere. So X is a function of rho and phi, and Y is a function of also rho and phi, and Z will be equal to Z. So we have to determine these things in all of these interchange of coordinate system. But to do that, what you need to have a good visualization of all these three coordinate systems. So let us do the next task 2, which is a bit more complicated. But if you go to the basic, it is very easy. Complicated things have different basic things. They are having means more number of basic logics which you have to apply, and a simple thing is composed of just one or two logics. Okay, that's why I'm saying this has to be a bit more complex, because it just needs you to have some more tools to understand. The tool is the visualization part. So let me take the second task. Second task was from XYZ to spherical coordinate system. Spherical coordinate system is R, phi and theta. Okay, this is what you have to do, and this part has been done very correctly by many of the students. But the sequential order is missing, means they are doing everything into the same problem. So not everything was necessary. So giving going step by step is the most basic part to understand. So let us say this is P, and we take the projection on xy plane. So this is x, this is y, this is z. Okay, so this is p dash. Now just subtend a right angle triangle. And here also you can subtend a right angle triangle on this. Okay, so this will be, see how I make these 3D diagrams. The thumb rule is that any line you make, it should be parallel to your that axis. So if I'm making this small rectangle, see what I'm doing. I'm creating a line parallel to your y-axis. This is the y-axis. So I'm creating a line parallel to this, and this small line I'm making it parallel to x. Okay, all the lines are parallel. So this is how you make a 3D diagram. So let's move on. So what we need to determine? We need to determine this x. We need to we are given this x, y, z. Okay. So this will be, if this is your these things, so we should make it line parallel to this. Okay, so this will be perpendicular. Just try to learn how I'm making this thing. Means it is also learning part, how you make your a good 3D diagrams on 2D papers, because visualization is very important. Okay, so what it is, we are given this x, y and z. X, y and z. Okay, so and what you have to do, you have to determine the length of this r. Now this is r, you have to determine this r. You have to determine this theta, what this angle makes with this z axis, this r, the radius of this sphere, what angle it subtends on z, and this phi. Okay, so means very simple it is. You have to determine what? You have to determine r as a function of x, y and z, phi as a function of x, y and z, theta as a function of x, y and z. Okay, so how you do this? So first dimension is very easy. So if you have got x, y and z, then what you can write? R has to be under root x square plus y square plus z square. Very simple thing. We have to talk about this, adding these three vectors. Okay, now what is your this phi? Phi you can write as, you need to calculate the second dimension, tan phi. So you can write tan phi as what? What will be tan phi? Tan phi will be your y by x, the perpendicular distance by the base. Okay, simple. So phi will be what? Tan inverse y divided by x. As simple as that. Now what is theta? What is theta? So theta is an angle that this r makes with this z. So first thing we can write is uh, uh, if which is the, just see which is the perpendicular part. So from here we need to subtend a right angle onto this z. So this will be right angle triangle. Okay, this will be right angle triangle. So if this is right angle triangle, then this will be your height. Okay, and what will be the base? So this will be your base. No? So just write tan theta. See, I'm going very into very basics using the your schooling concepts, trigonometry, basic trigonometry. So it will be this height. So what is this height? So height will be equal to your OP dash. Your this ZP is equal to your OP dash. So it will be OP dash divided by, or we can write in another word, let us do the second thing, the more easier thing. Write the cos theta. Cos theta will be what? The base upon r. Now r is the hypotenuse, and the base is what? OZ, and OZ is what? OZ is Z only. Now, and r is what? R you have determined. So it is x square plus y square plus z square. As simple as that. This is just very simple. If you can visualize the three dimension, you just have to apply some right angle formulas. Okay, this is as easy as that. Let us take it a bit more forward. Do some means I will say this has to be complex. Why I say this has to be complex? Because I want to do this thing. Cylindrical to spherical coordinate. Now just see how the things, how the visualization will help you out in doing the things. Okay, so what we need to do, we need to do convert rho phi z to r phi theta. So one method is there that you convert this to xyz and then convert back to r phi theta. But if you are having good visualization of these three dimensions, then you can directly convert these two. Just see how I am doing. Let us take the reference. Let us take a point P. Reflection of this point P onto your axis, onto your xy plane, sorry. So let us draw a line perpendicular to your x-axis and a line perpendicular to your y-axis. Okay, so what is that? So P. So you are having two things. One is this radius, What is this? This is r. And there is another radius of this cylinder in cylindrical coordinate system. You define it as to be rho. This phi is same, and this is theta. Now just see how you can do it. Direct transformation. Okay, this will be your okay. Now do this direct transformation. So what you need to do, you need to find three things: r as a function of rho phi z. Phi will be equal to phi, because both these uh, the definition of phi is same, and your theta in terms of function of rho phi. So one thing you know that if we take this this is origin O. So if we take OPP dash, then see what is OP dash in terms of R. OP dash in terms of R. So you will see that rho will come out to be, I am writing directly the equation, R. Because this is theta, this will also be theta, and you can easily see that rho will be equal to r sin theta. Okay, so we are able to determine your r in terms of rho upon sin theta, but we need this theta as well in terms of rho phi and z, so to reach to a ultimate expression of r. Okay, now the second dimension which you can directly find is applying this tan theta. So what will be tan theta? Tan theta will be rho by z. See, so theta will be what? Theta will be tan inverse rho by z. What you are having? Theta in terms of rho and z. Rho and z are cylindrical coordinate system coordinates. So one more thing is left, which is phi. So phi is equal to phi. Phi is equal to phi, and convert this to here. So you will get your r has to be rho upon sine of tan inverse rho by z. Okay, simple. Similarly, you can do for spherical to cylindrical coordinate system as well. So this you can take as your means you have to do it at your home and satisfy yourself, not me. You don't need to send the solution, but I will ask you to just do that part to have a better visualization of these 3D diagrams. Okay, now let us do some more tasks. What is that task? I will tell you. We know line, we know area, and we know volume. Okay, so what is the difference in these three? This is a single dimension quantity, 1D. There is only one dimension on which you can move, either here or here. This is a two-dimensional figure. You can move in here, here, or here, or here. So this is a two-dimensional figure. This is a three-dimensional figure. Okay, so you can move here, 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 in this dimension. Okay, which is remaining? Okay, here or here. So you can move in any of these. I will not talk about fourth dimension, that is out of your syllabus. So these three dimensions we have to see in different coordinate systems. This we have seen. Okay, this is very obvious. We need to see this. This gives you an extra hand. Let us do in XY coordinate system. Sorry. So this is X, this is Y, and this is Z. Now there are three axes in these three coordinates: X, Y, Z. When you will make an area, then it should be composed of two dimensions of these. If you take a single dimension, then you will get a line. If you take all the three dimensions, you will get a volume, space. But if you take two dimensions, then what are those things which you will see? Like if you take XY, make an area, make a surface that is composed of these two dimensions. So you can see now, you have to move in Y. So move in Y, move in Y, move in Y, go on moving in Y, and as well you can move in X. So what is this? This is XY plane. Okay, this XY, X-axis, Y-axis. They are composed of X-axis and Y-axis. Now let us see Y and X. Sorry, Y and Z. So what you will do, you will have to move in Y dimension and Z dimension. So Y dimension is the same thing, so I can go in here as well. What we are going in Y dimension, only moving in Y dimension, then move in Z dimension. This is what? YZ plane, your YZ area. The area made up of Y and Z dimension. Then do Z and X. So you have to move in X direction. And you can move in Z direction. So this plane is your xz plane, this is your xy plane, and this is your yz plane. Okay. Now let us talk about cylindrical coordinate system. Cylindrical coordinate. In cylindrical coordinate, what we have? Rho, phi, and z. Now just see how it goes. What are the surfaces which you will get by these three coordinate systems? Excellent. Let us take first of all rho and phi. So rho is a radial direction in xy plane. Okay, so we can draw a rho here. So all the radial direction will be having a rho. Okay, the same, it is same in here, it is same rho in here, it is same rho in here. Okay, and we have to complete the whole phi. So it means what you need to do, a phi start from x, so you have to complete this whole angle. So this is 360 degree. Okay, so if you take if you have to move in this in radial direction if you have to move, and as well as you have to move in this angular direction, then what you will get, you will get this thing, you will get a circle, not a circle, it will be a disc. Sorry, I couldn't get it properly. So it will be a, let me make this plane. Okay, so this rho and phi will be in which in means what will be the plane of this rho phi? It will be xy plane, it will lie in xy plane, and the disk will be at the origin. Okay, so you must be understanding this thing. Okay, now talk about phi and z. Means there is no rho, so we are not going to take the inner portion of this. We will take at some rho point, at some rho. Let us take at rho is equal to constant. Rho will not vary, only thing will vary, you will move only in phi dimension and z dimension, you will not move in rho dimension. So if you are not moving in rho dimension, then you are getting a circle, just a circle, not a disk, it will be a circle. Okay, and this circle will move, this circle will complete when you have moved in throughout the phi is 0 to 360, then you are completing your circle. Now you have to move in z dimension. So what is z dimension? Z dimension is in the z direction, and you can make a circle here as well, same circle with the same diameter. So what it will be, you are covering the whole curved part, and you are taking the z dimension. So what you will get a cylindrical curved surface. just cylindrical curved surface like a paper. If you roll the paper and make it as cylinder, then that surface will have dimension of phi and z. Okay, now let us talk about z and phi, z and sorry rho. Okay, so you have to move in z dimension, and what you have to move, you have to move in rho dimension. Okay, so can you think of what you will do? So let me make it a separate part, for this is a little hodgepodge. Okay, so let me make this to get a clear version. Okay, now you have to draw the surface with z and phi. Sorry, z and rho, na? Yes. Z and rho. Okay, so your phi is constant, and you have to move in rho. So let us make a line with rho dimension and whose angle is fixed. Now this is a point P that will lie on this OP. Okay, when we vary rho, then our P will lie on this OP line. Okay, now this line is your in rho dimension. Now just you have to move in z dimension. Okay, fine. So this is your z dimension, this is your z dimension, and this is your rho dimension. You are covering the whole rho and covering whole z, so you will be covering whole this plane. So you can make this plane, let us take a different color. So it is like a page of your book. If you take a single page of the book, then you can just see this. Okay, this will be just a sheet, and if you rotate this sheet, then how in which dimension it will rotate? It will rotate in phi. And if you complete this whole phi 0 to 360, it will make your whole cylinder. Okay, so this is how you can visualize in your cylindrical coordinate system. Let us move on to spherical coordinate system and just see the beauty. So this is spherical coordinate. In spherical coordinate, what you have r, you have phi, and you have theta. Just see how it goes. Now let us talk about r and phi. So what is phi? Phi is the same. You can rotate taking x as a dimension, and r is a line directly to a point P. So this is a point P, and the angle phi. So angle phi is you can see in here. Let me make the whole phi. You are not moving in theta. What you are doing, you are not moving it in this direction. in this direction. This is theta. This r, what it subtends with this z. So this you are not moving. You are only moving in your r and in your phi direction. So it will be what it will be. It will be a cone. Now let us take phi and z, phi and theta. Sorry. So what you have to do, you have to move in this circle, in xy plane, and you have to move in what? In your z. So r is fixed. So what you are doing, you are moving in theta direction and you are moving in circle. Okay, so you are not moving into this radius r plane. You are not moving inside nor moving outside. Okay, and you are moving in circular direction and theta direction. Okay, so what it will make? It will make the outer surface of a sphere, because the outer surface of a sphere will come, you have to make that you have to move in theta as well as in phi direction. You do not have to move in a radial direction, not in, not out. So it will be a, I will not draw that. It will be tough for me to draw that. So this will be uh, surface of a sphere. Okay. Now let us do for theta and r. Okay, what is theta? Theta is this thing, the angle which it makes. Let's first of all make this thing. Okay, you do not have to move in phi, so your phi is fixed. Okay, so your phi is fixed, and you have to move in theta as well as in radial direction. So at a particular phi, this will be a flat. This will be same thing which you have observed in your phi and z. Okay, so it will create a flat. Which is at an angle this will be at an angle phi. So your phi will be fixed and you will vary your r and theta. So varying your theta will cover your positive part as of this flap, and from 0 to 90 degree it will take the positive part of your flap, and from 90 degree to 180 degree it will take the bottom side of the flap. Okay, so this is a xy plane flap, and bottom to this is your negative flap, and above this is your positive flap. So it will create a flap like you did in this. So this is what. So your OZP dash P is a positive flap. Okay, so you can draw the negative flap as well. For positive flap, your theta will be equal to 0 degree to 90 degree for positive flap, and for theta is equal to 90 degree to 180 degree, it will be negative. So I expect that now it will be more easier for you to see the things in these three coordinate systems. And here I should finish this lecture, but before that, is there any question? Yes, there are some Wi-Fi is some kind of noise coming from your mic. 856. I'm not saying yes, sir. Okay. Okay, fine. If you missed something, then recording is there, so you can always record this thing. Fine. Thank you for now. I do not have any assignments for you for the uh, next class. Next class will be on your Wednesday scheduled class. Okay. Thank you for now. Thank you.